All right. Hello, my name is Maverick Collins. This is my video submission for shortest path in the weighted graph. And so we're tasked with building a script that would perform the Ditchka algorithm on a graph. And the graph that is referenced in this program is from the book. Um, Forgot the name of the book. The mathematical structures or for discrete logic, or anyhow, chapter 7, section 3, and it's problems 1 through 4. Um, and so the book problem was to perform the Ditchka algorithm on an unweighted graph. And then it was tasked with finding the shortest length and the distance. And so what I went ahead and did was I had to use a lot of resources. I used Geek for Geeks, other source here, to help get the structure of the program, and I had to use some AI to help refine it to get it to work. I spent a lot of time using this Geek for Geeks algorithm. It worked, but it didn't print out the actual path, and the distance was a little wonky. So I had to get some outside AI help here to help get it to work for the nodes and then to calculate the actual path itself, as we'll get into. So anyhow, what I had to do was initialize a few methods: add node method, add edge method, and then the actual Dishka method itself is referenced from Geek for Geeks, just checking straight from there. And so what this is going to do is go through the algorithm, and after it's initialized, this is initialized here to infinity for the Dishka algorithm. It's going to then set the whatever the start node is, go through, find the shortest node, and then add that to the subsequent path, and just keep building, building, building as the Dishka algorithm works. From there, it's going to calculate the shortest path. So it'll append each of these nodes and weights to this path, and then it'll spit out the path below here. So that was for problem, was that 4 to 7 is problem number 4, and it should have a ending weight of 4, and shortest path is from 4 to 3 to 2 to 7 for the book. So yeah, I think the hardest part was getting these all initialized and getting the edges correctly coded in. If they weren't correctly coded in, then obviously the algorithm's not going to work correctly. So without further ado, let's go ahead and run it. So I'll go ahead and do problem 4, which is from 4 to 7, 4 to node 7. And it goes ahead and says, hey, the shortest distance between nodes 4 and 7 is 4. Shortest path is from 4 to 3 to 2 to 7. And we'll run it again for problem 3, which I know has the answer. So 1 to 5. And it should be a shortest path of 6. It is. So from 1 to 5, it's going to go 1 to 2 to 7 to 8 to 5. And the distance is 6. So very challenging assignment. Had to use, like I said, a lot of resources to get it to work for the given parameters. I had it working before, but it wasn't computing the path and the totally the correct distance. So this iteration was able to do so. Um, yeah, this was a great class. I really enjoyed learning some pure mathematics, getting an introduction into the topic. Hopefully, don't have to learn too much more. And we got linear algebra in the fall, and that should be my last math class, sadly. Anyhow, Professor Nassar did a fantastic job teaching this course. He's a very sharp individual and great professor. So appreciate having the opportunity to take a class with him, to learn from him, just to glean, a little bit of information as much as I could from him in lecture. So appreciate your time, Professor. Appreciate the effort into making this class what it is, and yeah, hopefully this will go on and lead to a great career as a developer and engineer within the field. And yeah, thank you for your time and energy and effort for this semester. So this is Maverick signing out, and we will see you guys sometime soon. Thanks.